Hello viewers, in this video I am going to discuss some important and interesting problems of the chapter types of function. In the previous video I already discussed about the types of functions. There are so many types of functions I already discussed in the previous video, and I will also give you a link for that video, and if you are interested to see that video also, you can watch that video through my channel. So here the related problems, you see the first question of the chapter. So this is your first question. A equal to r minus 3, b equal to r minus 1 be two given sets, and prove that the function f a to b given by, this is the definition of the function given here, is a bijection. Bijection means you are to show that the function is a 1 and onto function. So you see the set A is equal to r minus 3 mean the set A is containing all elements, all real numbers except the point 3, and in the similar manner the set B is holding all real numbers except the number 1. So these are the two sets given, and the function is given here f a to b, and definition is this one. So we are to show that this function is a bijection, mean this function should be a 1 and onto function. So let us see the solution for the question. So to show a function is 1, first of all you are to take two different elements from the domain set. So here we are taking two different elements x1 and x2 from the domain set of the function is a. You see here this is the domain f a to b. So x1 x2 is taken from the set A, such that, so these two elements, you are to take these two elements in such a way that the images are equal for these two elements. That means fx1 equal to fx2. This means it is the image of x1 under the function f, and this is the image of x2 under the function f. So for two different elements you are taking two equal images. Now we are to check whether this for these two equal images we have pre-images are equal or not equal. That is our task. So see the next line. First use the definition of the function, this one here. Since fx is equal to x1 minus 2 divided by x minus 3, so here you are to use x1 minus 2 divided by x1 minus 3. So you see that it is x1 minus 2 divided by x1 minus 3, and on the right hand side also for x2 fx2 you just replace x by x2 here. You got my point. And take the cross product also. You take the cross product here, x1 x2, then thrice x1, then twice x2, then on the right hand side x1 x2, then twice x1, thrice x2, then 6. So cancelling the common terms from the both sides and taken all the terms in the on both sides and similar term cancelled, you will get final result as x1 is equal to x2. So what is the conclusion from here? You see we have taken here x1 x2 are two unequal elements, but if the images are equal, we see that actually that two elements was not unequal, they are also equal images, pre-images, and therefore this function satisfying the condition of 1 mean injective. So you can say that the function is a 1 function. So you can write here therefore f is 1. Next, to prove that this function is onto, so this time to check whether a function is onto or not, this time you are to take an element from the codomain set, from this one, from the codomain set you are to find take an element, and after that element, since you are taken the element from the set B, mean the codomain, therefore it will be the image, it may be the image of some elements of A. Is that clear? It may be, because you are taking the element from B, so it may be the image of some element of A. So we take that y from B such that y is image of some elements of A, and we are to check whether that element has the pre-image in A or not. That is our task. So let us take that one to check onto whether the function is onto or not. Let us take y is belongs to the codomain set. So y is taken from B such that y is the image of x under the function f. You take this one, and after that you use the definition of fx given in the question here. You see this is the definition of the function, so we apply that expression for fx here. So you see y is equal to, this is x minus 2 divided by x minus 1. So to obtain the pre-image for y from this equation, you express x in terms of y as like this, taking the product, then shifting x to the left hand side and 3y to the right hand side, as like this. X term is taken to the left hand side and taking common, so you will have y, and from here it is 1, 3y is going to the right hand side, so 3y, and minus 2 was already on the right hand side. Then from here the expression for x in terms of y is like this one. Now you see, this term is defined, this expression is defined only when y is not equal to, y minus 1 is not equal to 0, because otherwise if you take y minus 1 is equal to 0, then x will be undefined, x will be undefined. So this concludes that y is not equal to 1, mean y can take any value. And already we know that a function is onto when you can show a function is onto in two ways. One of the ways just checking whether for every y you have x in domain or not, or the second way of showing a function is onto or not, you just find the range of the function. Range mean the set of images. So you just find the range of the function, and if that range is equal to the codomain mean the set B, then range and codomain are equal, then you can say that the function is onto, because in the set B, in that case, in the set B there will be no free element, and that is why if in the set B no free element is there, then that means for every element of B must have an pre-image in A. So you see that one, thus the range of the function Rf will be equal to, it can take all values, therefore it is the set of real numbers R, but not the point 1, and so minus 1. And you recall the definition of the function given in the question. In the definition of the function, it was given that the function from the set A to B and where B was equal to R minus 1. You see the definition again, this one, f A to B, A was is equal to R minus 3 and B was equal to R minus 1. And here we see the range of the function is R minus 1, and the codomain of the function is also this one, is R minus 1. So the conclusion is the range is equal to codomain. So we write that one. So Rf is equal to B, mean range is equal to codomain. And hence you can say, since range mean the set of all images is equal to the codomain, mean in the codomain set there is no such element which has no pre-image in the set A. So you can obviously say that this function is an onto function. So therefore f is a bijection, mean it is an onto function. You may also write here, therefore f is onto. After that you write, therefore f is a bijection. So I think you understood this question. So let me go to another question of the chapter. Also you see, also you see this can also be think like this, There I already told you that there are two ways to show whether a function is onto or not. This is one of the way we are already discussed, and this is the second way, you see. So here you see, final result is x is equal to 3y minus 2 divided by y minus 1. And what is y? You see, y is taken from the set R minus 1, mean y is not 1. So for that values which are not 1, if you take such value, not 1, mean you can take 2, 3, 4, 5, 6, etc., or you may take some fractional number because the set is real number, so you can take some fractional numbers also. So if you take those values, you will get each time and every time the values of x will always be not equal to 3. It will be in A, mean it will be in R minus 3. Mean if you are not taking y is equal to 1, then you will not get x is equal to 3. So you can write like this line. So for all y is in the set B, there exists x is also in the set A such that fx is equal to this one. So fx is equal to x is this expression, applying here -2, and then after calculation you will get y, mean y equal to fx, mean x is the image of y under the function f. So this is one of the way. And you can see here, if you consider here, if you consider say y may be equal to say 1, y may be equal to 1. If you consider that, then if you take y equal to 1, then the function then the value for x is undefined. And if you take say x may be equal to 3, if you consider that x equal to 3, in that case what will be the conclusion? 3. Then after cross product, what you will get? It is 3y minus 3, and on the right side it is 3y minus 2. 3y will cancel from both sides, so left hand side is -3, right hand side is -2. After cancelling minus, it will be 3 equal to 2. So we will get an impossible case. We will get an impossible case. So therefore the conclusion is x cannot be equal to 3 for y cannot be equal to 1. For y not equal to 1, you cannot have x equal to 3. So for all elements in the set B, here you have written, I have written here, for all elements in the set B, there must exist x in the set A such that y is equal to fx, and hence the function is onto. So you may use this way or you may use this way, but I will prefer this method. This is very clear method. This method is. So you may use, but in your exam you may either use this method or use this method. Any method you can choose. But preferable method, this method is preferable for me. So you may also this method also. Okay. So now we can go to the next question of the chapter. Before that, you see. Before that, you see the answer of the question, the solution of the question can also be discussed through the graph of the function. This was the given function, fx is equal to x minus 2 by x minus 3. This was the given function. Here x is not 3. The graph of this fx function, this one, will be this green curve. Here you see you see this green curve here. This is the graph of the function fx is equal to x minus 2 by x minus 3. You see, in the definition of the function, it is given that x is not 3. Domain mean domain equal to r minus 3. It was given in the question. Domain mean x, values of x is not 3. You see here the line x is equal to 3 line is this one. And the graph of the function is nowhere touching or nowhere intersecting this line x is equal to 3. Therefore, x cannot be equal to 3. In that case, you see this function is 1, 1 and onto. Why this function is 1, 1 and onto? 1, 1 mean for every value, every different value of x in the domain, you will get different values of y in the codomain. That is the concept of 1, 1 function. I know we know this one. And you see, domain mean in the graph, domain mean the points on the x-axis. These are the points on the x-axis, and codomain mean the points on the y-axis. All of you know this one. Domain mean points on x-axis and codomain mean points on y-axis. And you see the domain of the function is the set of real numbers, mean all the points on the x-axis but not the point 3. So in that case, if you take any value from this x-axis, say you are taking 1, then in that case you will get for the point 1, it will have the image at this point. This is the point on the graph against the point 1. So this point will be the image of 1. It is I think 0.5, I think approximately 0.5, half mean. If you take 1 here, say 1 minus 2 is minus 1, 1 minus 3 is minus 2. Yes, it is half. You see, for 1 you will get half. As you take the point x is equal to say 0, then the point is 2 by 3. This point is 2 by 3 on the graph. Every point, for every point on x-axis, you will get, each time you change the value of x, you will get a changed value of y on the graph. Here also, if you take 4, then it is equal to 2. This point is 2. X equal to 4, it is 2. X equal to 5, then it is somewhere this one. So actually I am trying to show you that for every value of x, every different value of x, you will get each time different value of y, and so the function is a 1-1 function. And in case of onto, how you can obtain, or how you can show, how you can understood from the graph of a function that the function is an onto function. And that is very simple. You see, from the graph, if you take any point from this graph, say we are taking this point and go through for this point, is there any point on the domain, mean on the x-axis, exist or not? Yes, it is exist, this point. If you are taking this point, it has also a point in the domain. If you point this point, it has also a point in the domain. If you take this point, it will have also a point in the domain. If you point this one, it has also a pre-image in the domain set. So each and every point on the graph of this function, you will have a point on the x-axis, mean a point on the domain. So the function is also onto function. This is the way you can see whether a function is 1-1 or onto or not from the graph of a function. I think you understand this one. Now we can go through the next question of the chapter. Now you see this question. Show that the function f n to n, mean natural number to natural number. This is our function defined by, definition is given here. Fn is equal to n plus 1 by 2, whether n is whenever n is an odd number, and n by 2 whenever n is an even number, is not 1-1 function but onto function. This is our question. So you are to show this given function is not a 1-1 function but it is an onto function. That is our target. So here you see the values of n. Actually in general this is taken as x, but here in this special question it is given as n. So when n is a natural number, you see there are some natural numbers even and some natural numbers odd. We know that one. 1, 3, 5, 7, these are odd natural numbers. 2, 4, 6, 8, these are even natural numbers. So when n is an odd natural number, then you are to use the definition fn is equal to n plus 1 by 2. But whenever it is an even natural number taking n, then you are to use the definition fn is equal to n by 2 only. So for this function, whether this function is 1-1 or not, and onto or not, since the function is not 1-1, you have to show this function is not 1-1. So to show any function is not some 1-1 or not onto, if you want to show that one, just you find a counter example against or in support of the statement. The statement is not 1-1. So to support this function is not 1-1, you just find one example only. You see the examples here in the solution part. You see here, if you take n is equal to 1, then you are to use the definition of the function, this one, because 1 is an odd number. So whenever n is odd, then function should be taken as n plus 1 by 2. So f1 will be equal to 1 plus 1 by 2, that is 2 by 2 will give us 1. Is that clear? Then you take 2, say f2. This time you are to use the second definition, this one, because 2 is an even number. So f2 will be equal to 2 by 2 will give us also 1. So you see the image of 1 is 1 and image of 2 is also 1. That is 1 and 2 are two different elements but their images are equal, and this will tell us that the function is not 1-1 because different element has same image, but the definition of 1-1 tells us that different element must have different images. But here we have seen that different elements have same image, and therefore the function is not 1-1. Similarly, I am taking more examples here. f3, 3 is using here 3 plus 1 by 2 is 2, and 4 is using here 4 by 2 is also 2. So 3 and 4 are also different but their images are equal, and so on. So you can see that 1 is unequal to 2 but f1 is equal to f2. This breaks down the condition of 1-1. In the similar manner, 3 is unequal to 4, but f3 is equal to f4, and etc. So from this arguments you can say that the function is not 1 1. So you write therefore the function is not 1 1. The first part of the problem is solved. Now check for onto. So this time you are to take same concept, you are to take some element, an element, arbitrary element from the codomain set n, and we are to check whether for that element it has pre-image in the domain set or not. Domain set mean n. So actually for every natural number in the codomain, is there natural number in the domain such that these two elements are connected? That is our target. So let me write that one. You see here the oval diagram of the function. Function domain is the set of natural number, codomain is the set of natural number. You see here 1 image is 1, 2 image is 1, 3 image is 2, 4 image is 2, 5 image is 3, 6 image is 3, like this way. So two different elements same image, two different elements same image, two different elements same image, as like that. But you observe the codomain of the function, this one. You see if you take the natural number 1 in the codomain, it has two pre-images. If you take 2 in the codomain natural number, it will have also two pre-images. And you see for each element in the codomain set, whatever be the natural number you are taking in the codomain set, each time you will get two pre-images in the domain set. That means in the codomain set there will not be any free element, so that it has not pre-image, no pre-image in the domain. Each and every element of the codomain set must have some pre-images in the domain set. So it concludes that the function is an onto function. But in your exam you should not write this write like this. You are to use a manual method. You see that one. To check whether f is not f is onto or not, let us take y is in the codomain set, mean the set natural number, such that y is the image of n under the function f. Now use the definition of fn given in the question. This is the definition given. So from the first line you see, if you want to find the value of n, that means you are to express n in terms of y. From here you are to express n in terms of y. So n will be equal to this time twice y minus 1, and from this line it is simply twice y. You write that too. N will be equal to twice y minus 1, and from this line n equal to twice y. And so fn is equal to, fn mean the image, this one. Fn is equal to, is it equal to y or not? You see that one. Fn mean if n is an odd number, if n is odd, then you are to use this one, this one. So but by definition, this is the definition for odd. So n plus 1 by 2, and n should be replaced by twice y minus 1. We are using here twice y minus 1. 1 1 is cancelled, 2 2 cancelled, so it will be equal to y. And also fn is equal to, if n is even number, that means twice y, even number, in that case you are to use the second definition, n by 2, and n is equal to even as twice y. So twice y by 2, it will also give us y. So for even and for odd, for both cases we have the pre-image of the function, pre-image of the element y, and so this function is an onto function. So you can write this line for all this one. In both cases together we see that for all y is in the set codomain, there exists n in the set domain, such that y is the image of f under the function, y is the image of n under the function f, and that is why the function is an onto function. And to get a clear picture of this function is onto, you may see the oval diagram given in the previous screen of the video. Okay, so now we come to another part of the another question of the chapter. You see the question first. So question number 3, it is given, prove that the function f n minus 1 to n minus 1 mean all natural numbers but not the natural number 1. So from that set to the set of natural numbers the function is defining, and the definition of the function is given like this. You see, this is your function. Fn is equal to the highest prime factor of n. highest prime factor of n, mean the n, not 1, you see here, not 1. You can take 2, 3, 4, 5, 6, etc., but not 1. So each time you are taking the value of n, the image will be equal to the highest prime factor of that n you are taking. So if you see this definition of the function, and the question is asking for this function is neither 1 1 nor on 2. This is our question. So here also you are to show the function is not 1 1. Mean in this case also you find a counter example in support of the statement not 1 1. So for that you take the solution of the question. We observe that f2 will be equal to, in the language it will be the highest prime factor of 2, because you are taking n equal to 2. So highest prime factor of 2 will be equal to 2 itself, is not it? Similarly, if you take 3 here, then f3 is equal to the highest prime factor of 3. Is it not 3 itself? Yes. Okay. See more examples. f4 is equal to, this time the highest prime factor of 4, and this time it is 2, not 4, because you are finding the prime factor of 4, and that should be highest, and that is 2 only. Similarly, if you see f5, it is highest prime factor of 5 is 5 itself. f6, highest prime factor of 6, it is 3, and so on. Now you observe these results. You see here, f2 is equal to 2, f4 is also is equal to 2. That means 2 not equal to 4, but the images are equal. In the similar manner, 3 not equal to 6, but the images are equal, and this has broken down the condition of 1 1. Mean you can say that the function is not 1 1. Is that clear? So you write that statement here. Here we see that 2 is unequal to 4, but f2 is equal to f4. In the similar way, 3 is unequal to 6, but f3 is equal to f6, and so on. Therefore, this function is not 1 1. So you write that line. So f is not 1 1. Now to check or to show this function is not onto. So not onto mean what? This time in the codomain set, in this set, there are some element which has no pre-image in the domain set. That means here the function is defining by the highest prime factor of n. So this time you think about the range of the function. You think about the range of the function. So the range is what actually? Range is the set of the images of the function. So you see the images, you observe the image. These are the images. This one, this one, this one, this one, this one. These are images. You see the images. This is 2, 3, 2, 5. Each time the image is a prime number. By definition, you see the function. By definition, image will be always a prime number. That means the for those elements in the codomain set, which are the elements which have pre-images? The elements 2 has pre-images because 2 is prime. 3 has pre-image because 3 is prime. 4 is not 4 has the element 4 has no pre-image because 4 is not prime. You will not get as the image as 4. You see here, 4 will not be there. So 4 will be a free element in the codomain set. 5 has a pre-image because 5 pre-image is 5. 6 has a pre-image. No, sorry. 6 has no pre-image. 6 is not a prime number, therefore it has no pre-image. So in the codomain set, those elements which are prime has pre-images, but which are not prime will not have pre-image. Mean the range of the function is the set of prime numbers, but the codomain is the set of natural numbers, and so this time the codomain and the range are not equal, and so the function is not onto. Very simple. So again, the range of the function is the set of all prime numbers, and the codomain is the set of natural numbers. It is given in the question here, and range is obtained from here. You see. So the function is not an onto function. So therefore, range not equal codomain. So the function is not onto. So this completes the solution of the question. So now we go to next question of the chapter. You see the question: is the following functions f a to b 1 1 or on 2. Here I am taking some questions at a time. So this is one of the question, this is the second question, this is third question, this is fourth question. So these are the questions given here. You see one of the solution of this question. See, the set A is equal to 1 2 3 4, B is the set 1 A B C D, and the definition is given like this: 1A, 2B, 3C, 4D. Mean one image is A, two image is B, this one image is A, then for the element 2 image is B, for the element 3 image is C, and for the element 4 image is D. These are given. So the question is asking for these functions are 1 1 or not. So here you see for different element of the domain set 1 2 3 and 4, you have the images are also different, A, B, C and D. So function is a 1 1 function. And check whether each element of the set B is the image or not. Yes, it is image, D is also image, C is image, B is image, and A is also image of something of the domain set. Therefore all the elements of B are using, that means all the elements of the set B is used as the image of the function. Therefore function is also on 2. You see here the definition, the solution, very simple. You see the oval diagram. By this definition given, 1 image A, 1 image A, 2 image B, 3 image C and 4 image D. Therefore it is the condition of 1 1 and onto also, because no free element in the codomain set is. So therefore the function is 1 1 and onto. I have already discussed the details about 1 1 and onto in the previous video. So you can also see, I already told you that you can also see that video for better understanding this chapter. Okay, so these questions number B, C, D, you can solve yourself. You see one element image is A, two element image is B, here three element image is C, but the element D is free in the codomain set. So this time function is 1 1 because different element has different image, but D is free in the codomain set, mean it is not on 2 but it is 1 1. So this function is 1 1 but not on 2. And here also you see one image is A, two image is also A, three image B, four image C. So here you see 1 and 2, for both these two elements the image is A, so it has broken down the condition of 1 1, mean the function is not 1 1. Two element has same images, therefore the function is not 1 1. And you see whether every element of the codomain set are used or not. You see A is used, B is used and C is also used. So in the codomain ABC and all the elements are used, mean there will not be any free element in the codomain set, hence the function is on 2. So this function is not 1 1 but on 2. And see this function 1A, 2B, 3B. 2B, 3B mean it is not 1 1. And C is not using here, therefore it is not on 2. So neither 1 1 nor on 2. So let me go to the next question. Which of the following functions are injective and surjective? What is injective? Injective mean whether the function is 1 1 or not, that is injective, because the name 1 1 is also known as injective and the name on 2 is also known as surjective. So surjective mean whether it is on 2 or not, injective mean whether it is 1 1 or not. To check, so we take the functions. This is one of the function f n to n, fx equal to x square. Then you see the solution as done in the first question of the chapter. So here function is giving defining from n to n, natural to natural, and definition is this one. So you are to take two elements, different elements from the domain set n. So I am writing here x1 x2 belongs to n. Since domain and codomain these are equal, same, therefore you are to indicate whether it is domain or codomain. But we are taking x1 x2 from the domain set, so we have written here from domain such that the condition is same, fx1 is equal to fx2. You see this one, fx1 is equal to fx2. Now we have to check whether x1 equal to x2 or not. So by using definition, x1 square equal to x2 square, and from here since x1 and x2 are natural numbers taken, therefore actually shifting this one by factorizing this, you will get this one, because you see x1 plus x2 and both are natural numbers, so sum of two natural numbers cannot be equal to 0, but the product of these two factors equal to 0, mean either this or this factor or both the factors are 0, but here it is conclude that x1 plus x2 not 0, so we must have x1 minus x2 equal to 0. I have also written here that x1 plus x2 is not equal to 0, as x1 x2 is natural number. So from this we conclude that x1 is equal to x2, and therefore fx1 equal to fx2, implying here x1 is equal to x2, mean you can say that the function is a 1 function. So to check onto, this time you are to take the element y from the codomain set, and you are to check for whether for that y you have pre-image in domain or not. You see that part. Again, to check whether the function is onto or not, let y belongs to the codomain set such that y equal to fx, and putting fx x square, you see fx was equal to x square, so you use there y equal to x square, and from here express x in terms of y, mean x is equal to root over of y, x is equal to root over of y. We are not taking here plus minus because x was a natural number. You see the domain, x was a natural number, so negative number should not be there, so x is equal to root over of y, and this time y was what you see here, y was a natural number, and against every y, whether x is a natural number or not, this is natural number set, x is in the set natural number. So you see, if you take y equal to 1, obviously x is also equal to 1, mean x is a natural number. But if you take y is equal to 2, then x is equal to root over 2, and root over 2 is obviously not a natural number. So for the element 2 in the codomain, it will not have a pre-image in the domain, so the function is not on 2. So you can write this, it is not a natural number. For what it is not natural number? For all y as natural number. If you take for every y, x is not natural number. For some y it is natural number, because if you take 1, it is a natural number. If you take 4, then it is a natural number. If you take 9, then root over 9 is 3 is a natural number. But if you take 5, it is not a natural number against the element 5. So 5 will be free in the codomain set. So the function is not onto, because the definition of onto tells us that if there is any element free in the codomain set which has no free image in the domain set, the function is not onto, or image or the set of the image, mean the range is not equal to codomain. In that case also you can say that the function is not onto. So you see here, for example, I am taking an example here, y is equal to 2, and that is a natural number, because y should be natural number here, so we are taking y as a natural number. So in that case we see x is equal to root over 2 using here, and root over 2 it is not a natural number. Actually it should be a natural number to get onto, but it is not natural number because root over 2, this is not a natural number. So the function is not onto. Here I am giving just a single example. You may take 3, you may take 5, you may take 6, but if you take 9, in that case it will be a natural number. So there are much more elements in the codomain set n which has no pre-image, as like 2, as like 3, 5, 7, 8, 10, 11, 12. For these elements which are not a square number has no pre-image, so the function is not onto. I think you understood the question. Now you see, this is your next question. F z to z, mean integer to integer, fx equal to x square. Function definition is same, just changing here the set of integers. So this is homework for you, and you can solve yourself. Method is similar to the previous question, exactly similar. Just you should keep in mind that x and y, those are this time integer. Integer means this time all natural numbers, all negative numbers, integer number, mean -1, -2, -3, these are, as well as 0. These are the numbers in the domain and codomain this time. Okay, so you should keep in mind that one. You can solve yourself. So I'm going to the next question. fx, this time x cube, and function is z to z, again integer to integer. Let me solve this question here. Procedure is same. X1 x2 is in the domain set such that fx1 equal to fx2, you take that one, then using the definition x1 cube equal to x2 cube, then shifting to the left, expand this one by factor, you know that one, and from here this term is non-zero number, you see, because it is integer. If you take two different integers and taking the squares and sum as well, product of the integer and taking again sum, that term cannot be equal to 0. So x1 minus x2 must be equal to 0, since this is not equal to 0, you see here. Very simple. And from here you see x1 will be equal to x2, x1 will be equal to x2, and this tells us that the function is a 1 function. Okay, so you see the next part of the question. Next part means you are to check whether it is onto or not. So this time you are to take y in the codomain set. So to check whether it is onto or not, let y in the codomain set z such that y is equal to fx. And what was fx? Fx was this one. Fx was x cube. So use here x cube and express x in terms of y. So it is x is equal to y to the power 1 by 3. Now see, y was what? Next integer number. And think whether for all integers here, is x integer or not, because x should also be integer. X is the element of domain, this one, x is the element of domain, so x should also be an integer for every y as integer, every y as integer. So you see, if you take y is equal to say 1, in that case x is integer. Y is equal to 2, in that case cube root of 2 to the power 1 by 3, it is not integer value, it is a fractional number, point number. 3, 4, 5, 6, but 8 has the pre-image, because if you write y is equal to 8, then 8 is actually 2 cube, so 2 cube means ultimately x will be equal to 2, and 2 is actually an integer. So this time you will get the pre-image for those elements which are cubed number, mean for 1, for 8, for 27, for 64, and so on. In the negative part also, for -1, for -9, -8, for -27, and so on. But those elements which are not cubed number in the codomain set will not have pre-image in the domain set. So therefore, for every y in Z, mean codomain, there does not exist x in domain, so function is not onto. So here is not belongs to Z domain such that for all y in codomain, and therefore the function is not onto. You write that line. You may take one example here. Y is equal to 5, I am taking here codomain. Y is taken from codomain set, and we get x is equal to 5 to the power 1 by 3, and this is a fractional number, point number. It is not an integer. Actually x should be an integer to get onto, but it is not an integer. This is a simple example. You may take more examples. So the function is not 1. Always you should give one such example to support your statement. This one you take always in other cases also. If you are observing whether this function is not onto, then you give a counter example to support this statement. Okay, so you write, therefore the function is not onto. I think you understood the question. Let me go to the next question. Sorry, before that you may see the graph of the function also. You may see the graph of this function just discussed in the previous screen. You see the function was fx is equal to x cube, and it was defined from integer to integer. So why this function is 1, the condition of 1 is such that different element must have different images. If this condition is satisfied, you can say the function is 1. Already we proved in the previous screen. You see in the graph, I already told in another graph in this video that the points in the x-axis are the points of domain, and the points on the y-axis are the point of codomain, and the points on the graph are the points of range. Okay, so to check whether it is 1 1 or not, you see for different integer mean 1 2 3 4, these are not 0.5, not 0.6, not 0.7, those points you should not consider. You should consider the integer point, mean 1 0 1 2 3 -1 -2 -3, as well here also 1 2 3, not the intermediate points. You should avoid that points because the function is defining from integer to integer. So you see for the element 0, image is 0 because 0 0 is the point. For the element 1, image is 1, you see. For the element 2, image will be equal to 8. 8 will be somewhere in the upper part of this graph. No? Similarly, for -1, image is -1 because using -1 here, -1 cube is equal to -1, was 0 cube is equal to 0, 1 cube is equal to 1. So each time you are taking different integer, each time you will get different images. Therefore, the function is 1 1. And in case onto mean for every element in the codomain set, whether it has pre-image or not. So every element in the codomain set, you see this 3 is on the graph of the function, on the graph of the function, because something 3 is here. So 3 is on the graph of the function because it is an integer. But against 3, is there a point on the domain or not? You go vertically below the point 3 like this, below the point 3, the point will be somewhere 1 point something. But 1 point something, this is not an integer. It is not an integer, but by the definition of function given here, it should be an integer, mean 1 2 3 4 like this. But here we have seen that for the element 3 in the image, it has no pre-image. Similarly, but you see for the element 1, it has pre-image 1. For the element 1, it has pre-image. For the element 2, it has no pre-image because it is not integer. For the element 3, it has no pre-image because it is not an integer. Similarly, for other points also. So from this graph, we can also say that the function is not 1 1. I'm sorry. The function is an 1 1 function, but not onto function. I think you understood the solution of the question. So now we go to the next question. This is our question. F n to n is natural to natural, and the function definition is given x square plus x plus 1. This is our function, and to check whether this function is 1 1 and onto or not. So the method is same. You take x1 x2 in the domain set, this one, you say x1 x2 is in n such that fx1 equal to fx2, this one using this definition here. So x1 square plus x1 plus 1 equal to x2 square x2 plus 1, then 1 and 1 will be cancelled, shifting all the terms to the left like this, x1 square minus x2 square, x1 minus x2 equal to 0. Factorize this, x1 minus x2 will be common, this one factorization, then x1 minus x2 can be taken common, and from here you will have x1 plus x2, and from here you will have 1. But x1 and x2, these are natural numbers, so sum of two natural numbers then added to 1 cannot be equal to 0, so we must have x1 minus x2 equal to 0, this one, and from here it concludes that x1 is equal to x2, and which is the condition for 1 1. This is x1 equal to x2, so the function is 1 1. Therefore f is 1 1. And go to the second part of the question to check onto. So first of all, you take y is in the codomain set of the function. The function was defined from n to n, so codomain was also n. So let me take y belongs to n in the codomain such that y equal to fx. And what was fx? See the definition. This was fx, x square plus x plus 1, use here. So it is x square plus x plus 1, and now you are to express x in terms of y. X in terms of y mean this time you cannot directly find the value of x here. If this x is not there, then x square plus 1 equal to y, then x square is equal to y minus 1, x is equal to root over y minus 1. But whenever x is present here, you cannot directly write in that way. So what to do this time? This time you are to express this total expression in such a way that in a standard quadratic equation, and that can be done like this. You see, x square plus x plus 1, then this y is taken here minus y, and 1 minus y will act like a c, will act like c in the quadratic equation, mean it is ax square plus bx plus this is acting as c of the quadratic equation equal to 0. Now we can solve this equation, because ax square plus bx plus c equal to 0 has a simple formula for finding the solution. X is equal to minus b plus minus root over b square minus 4ac divided by twice a. So using that, you can write the value of x here. So x is equal to minus b is 1, then plus minus root over b square is 1 square minus 4a is 1, and c is 1 minus y here, divided by twice a is 1. Simplify it. It will be 4y minus 3, then minus 1 by 2. This will be the expression for x now. Now what was y? We have already taken y is in the set of natural numbers. So check whether for every natural number y is x again a natural number or not, because the domain of the function was also natural number. So for every y, if x, for every y natural number, if x is also natural number, then it is 1 onto. But if for some y it has natural number as pre-image, but for some y it has not natural number in the as pre-image, then you can say that the function is not onto. So here you see, if you take y is equal to 1, say, then 4 minus 3 is 1, then 1 minus 1 is 0, by 2 is 0, and 0 is obviously not a natural number. So I have written here that this expression will be not a natural number for all y as a natural number. So let me take one example here also, as done earlier. You see, this was our function, and if you take y is equal to 1, then I already told you that x is equal to 0, and that is not a natural number. So the function is not onto. This was the definition of function. Okay, so you see then the function is not onto. Now you see the graph of the function here. Now you see the graph of the function. This was the expression obtained in the previous screen for x. Y is natural number. You see, these are the domain points, these are the codomain points, but not these intermediate points. You got my point? Not this intermediate point, because the domain was natural number. Mean 1, 2, 3, 4. Not this way also. Only from 1, 2, 3, 4 here. And these are 1, 2, 3, 4 here. These are the codomains, elements of codomains, and the points on the graph are the range. Okay, so whenever I am taking y is 1, y mean this value is 1, we get the image pre-image as 0. If you take y is 2, y2, then pre-image is here, and that is not a natural number. Point something mean not a natural number. But when you go to 3, y is 3, then we will have a natural number 1. You see here, if you take 3 here, so 12 minus 3 is 9, and root over of 9 is 3, then 3 minus 1 is 2, and 2 by 2 is 1, this 1. So for 3 it has pre-image, but for 4, the element 4, it has no pre-image, because for the element 4 the pre-image will be 1 point something here, and that is not a natural number. So for the element 4 it has no pre-image, for the element 5 it has no pre-image, for the element 6 it has no pre-image, but for the element 7 it will have a pre-image 2, and so on. So I think you understood the graph as well as the solution of the problem. Okay, go through the video. In the next question you see, this is our next question. F z to z fx equal to x square plus 1. x square plus 5, and you can solve this problem very easily by using the previous methods. Similar question, f q minus 3 to q my q fx equal to this. Do not fear with this q minus 3. It is somewhere a subset of real numbers, but not 3. Q mean the rational number, mean it is the form p by q, but not the point 3. All points, all rational numbers, but not the point 3. You should exclude the irrational numbers, mean root 2, root 3, root 5. These numbers are not in the domain set. And in the codomain, all the rational numbers are given here. Function definition is this one. The procedure is exactly similar to the problems solved in the previous sections. So you can solve this problem also. This is a very simple question. You can solve this one. All these questions homework for you. Okay. But this question, I will solve this question for you. You see. R2 minus 1 1 to the set fx is equal to sin x. So this time the set of the domain is the set of real numbers. Real numbers mean it can take each and every value. You see the process of finding the 1 1 condition. So for that you are to take x1 x2 in the domain set. So we take that one. Let x1 x2 belongs to the domain set R such that the condition is same, fx1 equal to fx2, this one, and using this relation sin x1 equal to sin x2, we write here sin x1 equal to sin x2. Now you go to the first year classes. You have trigonometric equations. You have a chapter in the first year that I think the chapter was solution of trigonometric equations, general solution of trigonometric equations. This was the chapter in the first year. So from that chapter, if you have an equation like sin x is equal to sin alpha, then the solution is x is equal to n pi plus minus 1 to the power n into alpha. You got that? So I am writing that one because x1 and x2 are the set of real numbers. So you are to take x1 will be equal to n pi plus minus 1 to the power n into alpha is x2 here, this one, because n is belongs to R. So we are to take all possible values of x1 and x2. But in case if you have this domain as say minus pi by 2 or 0 to pi by 2, say domain is 0 to pi by 2, in that case you just take x1 is equal to x2, because in those cases the general value will not come, then the principal values will come. Principal values mean n is equal to 0. So if you take n is equal to 0, in that case x1 is equal to x2. So in that case the function is 1 1 if the domain is the set 0 pi by 2. But here the domain is given as a set of real number, mean you are to consider every possible values of x1 and x2. So here x1 is equal to x2 obviously for n is equal to 0, but x1 will also be equal to pi plus or pi minus something. So there are several values for which the function has same images. Therefore the function is not 1 1. I am giving one example here, say f pi by 6 equal to sin pi by 6. Pi by 6 is including in R, so it is equal to half. Then if you take say 5 pi by 6, f 5 pi by 6, then sin 5 pi by 6, sin pi minus pi by 6, it is in the second quadrant, so it is again sin pi by 6, and that is equal to half. So you see pi by 6 and 5 pi by 6, they are different numbers, but the images are same, and so the function is not 1 1. This is the conclusion. So the function is not 1 1. F is not 1 1. But in case, I already told you that in case this is 0 to pi, in that case you write only x1 equal to x2 from this line, and in that case the function is a 1 1 function. You got my point, I think. So you to go to the second part of the question. You see second part, just find the range of the function, and it is clear from the trigonometric function in the first year that the range of sine function is minus 1 1, because the value of sin x cannot exceed the point 1, and the value of sin x cannot beyond the point minus 1. Therefore its range is minus 1 1, and codomain is also minus 1 1. You see, so range equal to codomain mean the function 1 on 2. You see this question, complex number set to the real number set. Function is giving from complex number set to the real number set, and definition is fz equal to modulus of z. And how to find the modulus of a complex number? It is root over of real part square plus imaginary part square. That is the functional value. Okay, so let me solve this problem. xz1 is equal to this complex number and z2 is equal to this complex number. They are actually different complex number because it is plus, it is minus. So z1 z2 are two different complex numbers, but if you find the image of z1, fz1 will be equal to, by definition, mod z1 equal to root over a square plus b square, and similarly for z2, fz2 mod z2 is equal to, it is also a square plus b square. And you see, for both these two complex numbers, different complex number, but the images are same, and so the function is not 1 1. So z1 not equal to z2, but fz1 equal to fz2. Therefore f is not 1 1. Okay, so you go to next section. So to check whether this is onto or not, take y belongs to the set of real numbers R such that y equal to fx, not fx this time, or fz, because function is given as z, fz. So in that case, you see y is equal to fz mean always mod of z, and mod of z, whatever be the complex number z is you are taking, in all cases the value of mod z is either 0 or more than 0. It is very clear. And so ultimately y is greater or equal to 0. So what is the range of the function? You see here, range of the function is the set from 0 up to infinity. So therefore the range of the function is from 0 up to infinity. But the codomain is what? Real number set. You see here, real number set. So codomain and range are not equal, and therefore this function is not onto. So but the codomain of the function is the set of real numbers, therefore codomain and range are unequal, so the function is not onto. I think you understood the solution. Okay, we go to the next part. This is your question now. Show that the function f R2 are defined by fx equal to modulus of z is neither 1 1 nor onto. Just give you counter example in support of these two statements. So you see here, we observe that 2 and minus 2 both are belongs to the set of real numbers domain, but f2 is equal to modulus of 2 is 2, f minus 2 is equal to modulus of minus 2 is also 2. 2 and 2 are different numbers, 2 and minus 2 are different numbers, but images are equal. Therefore it has broken down the condition of 1 1. So 2 not equal to minus 2, but f2 is not equal to f minus 2, and hence the function is not 1 1. Therefore the function is not 1 1. So for onto part, obviously you see the range of the function is what? You see here, range means the set of images, and image is always a positive number because it is modulus, positive as well as 0. So 0 up to infinity, this is your range. But what is codomain? It is R. So range and codomain are not equal. Function is not onto. You see here, let y belongs to R, the codomain, such that y equal to fx and fx equal to mod x, and mod x is always greater or equal to 0. Mean y is greater or equal to 0, mean the range is equal to 0 up to infinity. Positive part mean non-negative real numbers. So therefore the range of the function is 0 up to infinity, but the codomain is the set of all real numbers. It is given all the set of real numbers. So therefore range and codomain are unequal, and so the function is not onto. Okay, so go to the next question. This is your next question. Show that the function f R2 are defined by, this is definition, fx is equal to this one is neither 1 1 nor onto. Again in support of this statement you give counter example. So very simple, whenever x is less than 0, whatever be the value of x, if it is less than 0, mean minus 1, minus 2, minus 3, you may take fractional number also, because domain is set of real numbers. Okay, so any value which are less than 0, in all cases the image is what? Image is minus 1. Any value of x which is greater than 0, mean 1 2 3 4 etc., as well the fractional point also, because it is real number. So for any value which is positive number, in all cases fx will be equal to 1. This function is not 1 1. Very simple. Why it is not 1 1? If you take say x is equal to, you see the solution. We observe that f2, 2 is a positive number, so f2 will be equal to 1. f3 is a positive number, so it is also is equal to 1. So 2 and 3 they are unequal, but f2 is equal to f3, so function is not 1 1. 2 not equal to 3, but f2 equal to f3, etc. You can take the example from the negative branch also. Therefore f is not 1 1. Okay, so to check it is onto or not, to check onto, just see the range of the function. What are the range? You say whatever the value you are taking for x, either it may be less than 0, or it may be greater than 0, or it may be equal to 0. In every cases you will get the image is either -1 or 0 or 1. Except these 3 points, you have no image in the codomain set. So the range of the function is the set -1, 0 and 1. So you write clearly the range of the function Rf is equal to -1, 0 and 1, and the codomain is the set of real numbers. Here you see real number set. So the function is not onto, because range and codomain are unequal. So range not equal codomain, function is not onto. This completes the solution of the problem. Okay, so you go to the next part. This is our question now. Show that the function f r to r defined by fx equal to, this is the symbol of greatest integer function you studied in the first year class, greatest integer function. Here it is also given that this is representing a greatest integer less or equal to x, is neither 1 1 nor onto. Again the same concept. You give counter example to support this statement, not 1 1 not onto. To support that statement you give example. So let me see the example here. It is seen that f of 2.7 mean greatest integer of 2.7, and greatest integer definition is you are to leave the fractional part. You are to take that integer which is just less than 2.7. So 2.7 just less than the first integer less than this one is 2 obviously. That is, you go from the point on the real line, from the point 2.7 you go to the left of that point 2.7, and the first integer you obtained, and that is 2. So the result is f 2.7 is 2. Similarly, if you take f 2.4, in that case also from the point to 2.4, if you back to the left, you will get the first integer as 2. So the image of 2.4 is also 2. So 2.7 and 2.4, they are different real numbers, but the images are same real number 2. You may take other examples, say to 5.7, image of 5.7 is 5, image of 5.2 is also 5. So 5.7, 5.2, they are unequal, but the images are equal. So you can take any other example. Okay, so I am taking here 2.7 is not equal to 2.4, but f 2.7 equal to f 2.4. Therefore the function is not 1 1. Okay, this is the line. And onto mean, again you just think about the range of the function. Range mean the set of images. So what are the image here? The image, each time you are taking any real number, each time you will get the image as an integer. Always you will get integer. Fraction part will be removed from greatest integer function. So range is an integer function, all integer function. But codomain is what? Codomain is the set of real number. So integer and real number set, they are unequal, and so the function is not onto. So you write here, we know that fx equal to this is always an integer, thus the range of the function is the set of integers, but the codomain is the set of real numbers. Therefore codomain and range are unequal, so function is not onto. I think you understood the question. Let me go to the next section of the chapter. This is our new question. Show that the function f r star to r star defined by fx equal to 1 by x is 1 1 and onto. This is the question. And what is r star is representing, giving here. R star is the set of all non-zero real numbers. Mean r star is equal to all real numbers but not the point 0. Is that clear? Then the next part of the question is set of all real numbers. Is the result true? Mean is the function 1 1 and onto if the domain r star, this one, is replaced by the set of natural numbers. That is the second part of the problem I will discuss later on, but first target is to show this function is 1 1 function and onto function. So let me show that one. Very simple. x1 x2 belongs to r star. Very simple. These methods are similar such that fx1 fx2 1 by x1 1 by x2, because definition is this one, and it will imply x1 equal to x2, so function is 1 1. Then take y equal to, y belongs to this codomain set, so y belongs to r star codomain such that y equal to fx. Okay, then fx is 1 by x, 1 by x, so x will be equal to 1 by y, and y was also r star. Y this is defined only when y is not 0, and so domain what is the range from here? Y not 0, but take every point, so it is r minus 0. So rf is equal to r minus 0, and r minus 0 by definition of the function given in the question, that it is r star. So rf is equal to r star mean equal to codomain. Rf mean range equal to codomain. So range equal to codomain. Function is onto. Okay. So now come to the second part of the question. The second part was asking if the domain set r star is replaced by natural number, then the function is 1 1 or onto, 1 1 or not, onto or not. So in case if you take the domain as n, then obviously the function is 1 1, because x1 equal to x2, 1 by x1 equal to 1 by x2 will give us x1 equal to x2, whatever be x1 and x2 is. So x1 x2, if they are natural numbers, in that case 1 by x1 and 1 by x2 will give us x1 equal to x2. So ultimately, if the domain set is replaced by the set of natural numbers, it will be it will remain 1 1 1 1, but not onto. So again, if the domain of the function r star is replaced by n, then the function remains 1 1. That is, in the previous screen you have the 1 1 part, so it will remain 1 1, but not onto. Why it is not onto? Because this time you see, y is what? Y is the element of codomain. Codomain is r star. Codomain is not changing here. Domain is changed. So if you take y as any real number, say y is equal to 5, say, but it should not take 0. Y is equal to say 5. In that case, x is equal to 1 by 5. So this time x is equal to 1 by 5. This time the domain is natural number, but 1 by 5 is not a natural number. So for the element 5, in this case, it has no pre-image. Therefore, the function is not onto. But if the function have the domain as r star, in that case 1 by 5 is actually r star. R star means not 0. Therefore, it is onto. But whenever you change the domain by the set of natural number, the function will not be onto. But if it is r star mean non-zero, then it is onto. Is that clear? Okay, come to the next question. This is the question. This time the domain is the Cartesian product of two sets, z cross z, Cartesian product, and the codomain is the set of integers only. Function given f mn is equal to m plus n. So this time the domain is the set of Cartesian product. Cartesian product means this time the elements of the domain set are the set of ordered pairs. Ordered pairs like this, a b type, this one. So hence the definition of the function is given like this. So f of the element mn will be equal to sum of these two components of the ordered pair, m plus n. It is given. The question is, show that f is onto but not 1 1. So again, give counter example to support this statement. Okay, so you see here clearly 2 4 is an element of z cross z. Okay, then f of 2 4 by definition it will be equal to 2 plus 4 will be equal to 6. In the similar way, if we take say 5 1, 5 1 is also an element of z cross z, but f5 1 will be equal to 5 plus 1 is again equal to 6. You see 2 4 and 5 1, they are different elements, but images are equal. So it has broken down the condition of 1 1. So function is not 1 1. So 2 4 not equal to 5 1, but f24 equal to f5 1, thus the function is not 1 1. Okay, so come to the second part. in the to show this is 1 1, this is not sorry, to show this is onto, function is onto. So this time you are you cannot give example, this time you are to show. So therefore you take y belongs to the codomain. So let, I am taking a here, you may take also. So now let y belongs to z, mean this codomain, I am writing here codomain. Then a can be expressed as the sum of whatever be the integer here, any integer, say it is 5, then 5 can be expressed as the sum of two different integers, is not it? So whatever be the integer you are taking here, that integer can be expressed as the sum of two integers, and as you express that number as the sum of two integers, consequently it will have the pre-image mn in the domain such that fmn is equal to a. Okay, this one fmn is equal to a, therefore function is onto. Very simple. Okay, so I think this question is you understood this question. Okay, so we go to the next one. Now you see this question, if a and b are two non-empty sets, prove that the function f a cross b to b cross a such that f a b equal to b a for all a b belongs to a cross b. So this is also slightly something similar to the previous question. This time domain and codomain both are cross product set, Cartesian product set. So in the domain and the codomain the elements are of ordered pair like this. So f a b is equal to BA. This is the definition of the function given. So you are to prove this function is a bijection, mean it is a 1 1 and onto function. So come to the solution of the problem. So AB, CD, two ordered pairs are taken in the domain set like this. Actually in general we take x1 x2 belongs to the domain, but here we are taking x1 mean AAB and x2 means CD like that. So FAB equal to FCD you are to take FAB FCD. AB mean by definition BA and CD mean by definition DC. You have to reverse the ordered pair only. So by the property of ordered pair you can say B equal to D and A equal to C. B equal to D, A equal to C, and this can be written like this: A equal to C, B equal to D, just changing the order only, and then it is AB equal to CD because it will also implies A equal to C, B equal to D, this one. So our supposition was FAB equal to FCD, and finally we obtained AB equal to CD. That means fx1 equal to fx2 implies x1 equal to x2, mean the function is a 1 1 function. Okay, so you write that line, therefore f is 1 1. And for onto you take any element in the codomain, mean of the form BA type. So again let BA belongs to B cross A. We must have AB belongs to A cross B. It is the property of Cartesian product, because BA belongs to B cross A, mean AB belongs to A cross B. So such that FAB equal to BA. So in all cases, as you take any ordered pair in the codomain set, the reverse ordered pair will be in the domain set in all cases. So it shows that the function is onto. So thus we can say that for all BA belongs to A cross B, there always exist AB belongs to the codomain domain set A cross B such that FAB equal to BA. Therefore the function f is onto, hence it is a bijection. Okay, so go to the next one. This is your question now. Let A be a finite set and f a to A is onto. This is given, and you have to prove that this function is 1 1. That means if f is a finite set to the same set is a function, if it is onto function, then obviously it is an 1 1. It is a 1 1 function. You have to prove that one. So you go to the solution. So let me take a finite set A equal to x1 up to xn, finite set, and the range of this finite set will be equal to set of the images, mean fx1, fx2, fx3. These are the images of x1, x2, x3, etc. So RF range is equal to this set. But the question is given, in the question it is given that the function is onto, mean this range is equal to this codomain, mean A. So it is given that f is onto, so we must have range equal to codomain. So range equal to codomain. Range is this one, so this one, and codomain is this set. A was this, and two sets are equal. These two sets are equal mean every element of the sets are equal and distinct. Okay, so which is a set of distinct elements? These are distinct element, n number of elements, because on 2. These are also distinct element. These two sets equal mean these are distinct, mean these are also distinct. Therefore fx1, fx2, fx3, these are also distinct element. So distinct element, distinct image, function is 1 1. So hence a to b is 1 1. Very simple. Okay, then the reverse question again like this: a is a finite set, f a to a is, this time it is 1 1, then it is on 2. This is the question now. So this is your question now. A is a finite set, then prove that it is 1 1 given this time, and you are to prove this on 2. So if A is finite set and function is a to a, if the function is 1 1, then it is on 2. If the function is on 2, then it is 1 1. Okay, so earlier one, the previous question already solved. This time it is given 1 1, and we have to prove that it is on 2. So let me solve this question. Very simple. Let A is the finite set, this one be a finite set, distinct element. In order to prove that it is onto function, we have to show that every element of the set A has its pre-image in the set A domain. For every element of this, there exists pre-image in this. Okay, in other words, we can show that range is equal to codomain. Okay, so let me write that one. Since f a to a is an one-on function, therefore the images, these are the images, are also distinct element, because one-on function mean different element, different image. Different mean distinct image. So these are distinct element. So but the codomain has n elements, because codomain is a containing n elements, and these are also n elements. Okay, and the function is on 1 1. So a is equal to this set. This is the set of range set, and codomain set is this. So a must be equal to this one, and so codomain equal to range, and hence the function is on 2. Very simple, need not to discuss more here. We go to the next question. Now we have this question. Show that the function f r2 are defined by, you see the definition of the function, this one, fx is equal to x by x square plus 1 for all x belongs to R is neither 1 1 nor on 2. You see in this question it is asking for the function is not 1 1 and not on 2. So in case we are to show that a function is not 1 1 and not on 2, we are to take actually some counter example to support the statement given in the question. This is our procedure actually. But you see in this question, actually this time you cannot take the example, counter example to support the statement easily from here, because if you take say 1 or 2 or 3, in that case you will see that the function fx, that is f1, is a different image, has a different image, f2 has also a different image, f3 has also a different image, and in that way it will proceed. So at the first sight you will see that this function actually may be a 1 1 function, because at the first sight we see that the different element in the domain set, it has a different image in codomain set. But actually you are to show that the function is not 1 1 and not on 2. So for that types of question where the example cannot be obtained easily, you are to go through by usual method, mean by taking x1 x2 belongs to the domain set, then fx1 equal to fx2, that way. After that, from the last line where the conclusion is obtained as whether it is onto or not, from there you can find the example. You see the solution here. So let us take x1 x2 belongs to the domain set R, this domain set, then fx1 equal to fx2, then using the definition of the function, then by taking cross product, then by taking all the terms in the left hand side and taking common like this, and then factorization, and then x1 is equal to x2 and x1 is equal to 1 by x2, you see here. So from here you see for the element x1 and for the element 1 by x1, actually for the element x2 or for the element 1 by x2, for these elements we must have same image. we must have same image. Let me take one example. Say if you take say x1 is equal to 2, then fx will be is equal to 2 by 2 square plus 1 is 4 plus 1 2 by 5. And if you take x is equal to half, that is reciprocal of 2, as like here reciprocal of 2, then it will also be 2 by 5. You see the example here. So here the conclusion is the function is actually not 1 1. So therefore the function is not 1 1. You see the example for this one. Now say x1 is equal to 2 and x2 is equal to 1 by 2, then fx1 will be equal to x1 by this one. So you are taking x1 is equal to 2, so it is 2 by 2 plus 1 is 2 by 5. Then x2 is equal to half, that is reciprocal of this 2. So half by 1 by 4 plus 1, by taking LCM you will get finally 2 by 5. You see, for the element half and for the element 2, both have the result same, that is image same. So function is not 1 1. So you take x1 is not equal to x2, but if x1 equal to x2, so f is not 1 1. This is the example. Okay, come to the second part. Let y belongs to the codomain set. That codomain set was also R, such that y equal to fx, you take this one, and then putting fx is equal to the expression. This was the function f, and fx is equal to x by x square plus 1. So apply here, y is equal to this one. So from this equation you have to express x in terms of y by taking cross product. You will get this one, but this time you cannot directly obtain x from here, because the term x is present. If this x is not present, then you can find x, because it is in that case there have the possibility to obtain the value of x from the equation, but this x is present here, so you cannot take common or something else. So you write like this: y x square minus x plus y, and this is a standard quadratic equation, that is ax square plus bx plus c is equal to 0 time. We have already done this types of problem in earlier screens, if so you know that one. So from here you can write y is equal to minus b, that formula is used here, and go to the next screen. You see this one, x is equal to, this is the expression, and also you have the function, this one. Now you see, we are taking y as a real number. Already in the previous screen you see that the y, number y, is taken in the codomain set R. So x mean the domain must also be R. So you check here, for all y belongs to this R, whether x is also real number or not, mean R or not. You see, it is not possible for all y. If you take say 1, y is equal to 1 is obviously a real number. In that case 1 plus minus root over minus 3, and minus 3 root over is a complex number. That means for the element 1 in the codomain set, it has no pre-image. Obviously you can obtain that one. So actually this function is not onto, but this can be done by obtaining the range also. By obtaining the range you can also find the function whether it is onto or not. So here I am using the range system. So this is defined if this term, this inner term, that is under the radical sign terms, should be a positive number. So 1 minus x, 4y square is greater or equal to 0, 4y square less equal to 1, y square is less is equal to 1 by 4, and that will imply, it is known from your first year classes, that it is minus half less than equal to y less than equal to half. So this is your range. Do not think about y is equal to 0 here. Actually this question may arise in your mind that y cannot be equal to 0 because y is coming here as a denominator. But you see the definition. If you take y is equal to 0, x is equal to 0, then y mean fx is also is equal to 0. X equal to 0 mean x is also is equal to 0, or x is equal to 0 mean y mean fx is also is equal to 0. Mean that for the element 0, image is 0. And conversely we can say that for the element 0, pre-image is 0. That means if y is 0, then there is image. So y may be equal to 0. From this line you can obtain that y may be also equal to 0, and that is why you should not consider that line y not equal to 0 from here. Though at the first sight, though the question arises that this is greater than 0 and y not equal to 0, this question will arise conveniently. But at the same time, you should also see the definition of the function, whether y can be equal to 0 or not from the definition. Y mean fx actually. So fx can be 0 or not. And obviously fx can be 0 because x may be 0 because x is a real number. So 0 divided by 1 is also 0. Therefore, y has the image, and therefore y equal to 0 has the image, and therefore x is equal to 0. X x is equal to 0 has the image, and y is equal to 0 has the pre-image, and therefore we are not taking that line. So from here you can write the range of the function. So therefore the range of the function is minus half half, and the codomain is R. Therefore range and codomain are unequal, and so the function is not onto. So but the codomain is R, range not equal to codomain, and so the function is not onto. You try to understand the previous question with the help of graph. In the previous question, we already showed that shown that this function is neither 1 1 and nor onto. So why this function is not 1 1? In the solution of the question, we already discussed that for the element half and for the element 2, for these two values of x, we have equal images. And you see this graph, half mean 0.5 and 2 is 2 itself. You see for the element half, the image is this one, and for the element 2, the image is this one. You see this value, y value mean this length, and y value mean this length are same, equal. You see here are equal, but the values of x are unequal. So for these 2 points, you will have a same image in the range or in the codomain. Similarly, for minus half, this point, for minus 2, this point has the same value. Therefore, this function is not 1 1. You may take other points also. I am taking half and 2. You may take 5 and 1 by 5 also. 5 and 1 by 5 must have same image. 5 will be somewhere on the right part of this graph. So the function is not 1 1. And again you see why the function is not onto. Because it is not onto because the codomain of the function was given as the set of all real numbers. Codomain means the points on y-axis. This total entire axis, entire y-axis is the codomain. But range is what? Range means the part of the codomain set, the section of the codomain set where the images of the function are remaining, and that images mean the points on the graph of the function. And you see on the graph of the function, the points is not crossing the point half. You see highest value is half and lowest value is minus half, and after that all the points will remain inside minus half and half, but the codomain was actually the set of real numbers. So codomain mean this total set is not equal to range, mean minus half up to plus half, and therefore the function is not onto. I think you understood the question very smoothly. Okay, so we go to the next screen with a new question. This is our question now. Show that the function f r to this set defined by the function is given here, fx is equal to x by 1 plus mod x, and the domain is the set of real numbers you see here. So x belongs to R in is 1 1 and onto. This function should be shown as 1 1 and onto. So first of all, in this question you are to remove this modulus sign by taking x as a positive number or by taking x as a negative number. Before going through the solution of the problem, you are to remove the modulus sign. That will be easy for you. So let me solve the question. This is our function given fx. Then we expand this. Fx is equal to, since we are taking x is positive, therefore mod x replaced by x, and where we are taking x is negative, then mod x is replaced by minus x. So this is our new function now. Now we want to prove this the function as 1 1 for 1 1. This function is 1 1, and therefore there actually there are 4 cases arises. Whenever you take the points x1 and x2 as positive, that is one of the case. Whenever you take x1 and x2 as negative, that is the another case. Whenever you take x1 is positive, x2 is negative, that is the third case. Or finally x2 is negative, x1 is positive, that is the fourth case. Okay, so you take the cases step by step. So let me take the first case. Let x1 x2 belongs to R such that x1 not equal to x2. Okay, so now we may have, since x1 and x2 belongs to real number, but x1 and x2 are unequal, but whether these are positive or not, that is case 1. So case 1, x1 and x2 they are positive numbers, so we are to use this definition of the function positive. This is x positive, so this one you take that one, x1 not equal to x2, mean 1 plus x1 will also be not equal to 1 plus x2, and mean x1 by 1 plus x1 is also not equal to x2 by 1 plus x2. So fx1 is also not equal to fx2. This is also one of the way to show a function is not 1 1. You may use the previous method also. So you see here, in this case the function is 1 1. Then go to the case 2. Say x1 and x2 both are negative numbers. Then therefore we are to use the second line of the definition of the function. So x1 not equal to x2. 1 minus x1 will also be not equal to 1 minus x2. x1 by 1 minus x1, x2 by 1 minus x2 are also unequal. So fx1 unequal to fx2. So in this case also the function is 1 1. The function is 1 1 in this case also. Next go to the case 3. This is the case 3. x1 is positive, x2 is negative. So x1 and x2 obviously unequal because one of them is positive and other is negative. So obviously they are unequal. So fx is equal to fx1 is equal to, for this element, since x1 is a positive number, so fx1 will be equal to x1 by 1 plus x1, and that will also be a positive number. Whatever be the value of x1, if you take any x1 as a positive number, this total number is also a positive number, and that is why we have written fx1 is also positive number. And in case x2 is a negative number, then you have to use the second line of the definition, that means x2 divided by 1 minus x2, and that will be also a negative number. Say let me take x2 is equal to minus half. So minus half divided by 1 minus of minus half, that is 1 plus half. So minus half by 1 plus half is obviously a negative number, so less than 0. So ultimately x1 is unequal to x2 and fx1 is positive, fx2 is negative, mean fx1 and fx2 are also unequal. So you write that line, fx1 is unequal to fx2. So in this case also the function is not the function is 1 1. So this one, and the final case is x1 less than x2, x2 greater than x1 less than 0 and x2 greater than 0. So similar manner, in this way you can take like this. So this is less than 0 this time and this is greater than 0. fx1 fx2 are unequal, so function is not function is 1 1 in this case also. But you see, you may in your exam you may take case 3 or case or you can take case 4. It is not necessary actually to take both these two cases in your exam. You can take the third case or you can take the fourth case, or you may take both of them, but it is not necessary. It is not necessary, you can take any one of them. Okay, so in all possible cases we see that this function is 1 1. So you write that line, thus the function is 1 1 in all possible cases. So the first part of the problem is done, and we go to the second part, mean this time we are to show that the function is also onto. So go to the second part of the problem. For the second part of the problem, you take y, that is to show the function is onto, you take y in the codomain set. This is the codomain set given in the question, and y is actually this codomain, mean x is between -1 and 1 and x is belongs to R, mean this is the open interval minus 1 1 such that y is equal to fx. This one using the definition of fx got in the previous screen. This is fx, and now you just try to find the range of the values of this expression and range of the values of this expression. This expression should be calculated for x greater than 0, and this expression should be calculated for x less than 0. So let me take for x greater than 0, take that one. So whenever x is a positive number or x is greater or equal to 0, in that case x divided by 1 plus x, this expression x divided by 1 plus x, whatever be the value of x is taken, say 1, then 1 by 1 plus 1 is 1 by 2 is less than 1, 2 by 1 plus 2 is 3, so 2 by 3 is also less than 1. In all cases, say x is half, then half divided by 1 plus half, it is also, you may calculate in your copy, it is also less than 1, and so on. In all cases, x divided by 1 plus x mean some number divided by 1 plus that number, it is obviously less than 1, and it may be equal to 0, because if x is equal to 0, then 0 by 1 plus 0 is 0. Okay, so the values of this expression mean x by 1 plus x mean y, this one is 0 up to 1. Okay, so come to the next part, that is taking x less than 0. So when you take x is less than 0, in that case you are to take this expression x divided by 1 minus x. Whatever be the value of x as a negative number, say it is minus 1. So minus 1 divided by 1 minus of minus 1 mean 1 plus 1. So minus 1 by 2, final result. Minus 1 by 2 is a number greater than minus 1. If you take 2 minus 2, then minus 2 by 3 is also a number greater than minus 1, and so on. You may take fractional values also. For the point x, you may take fractional value, and in that case also you will get, or you will see the number will always be greater than minus 1, and it cannot be equal to 0. It is always less than 0, because a minus will always remain here. So this is a negative number and a number which is greater than minus 1. So this can be replaced by y. So we have written y here. So this one. So if you combine these two, actually y is beginning from minus 1 up to 0, then 0 up to 1. So you can take y is actually from minus 1 up to 1. So combining these two, you can write minus 1 less equal to y less is equal to 1. That is, y is belongs to minus 1 1 open interval, and this is the range of the total function. So range mean RF is equal to minus 1 1, and actually this was the codomain. You see, this is the codomain. So the function is onto. So the function is onto, and that completes the solution of the problem. Okay. You see this fresh question. Consider this function f, the open interval 0 pi by 2 up to the set of real numbers. Definition is fx equal to sin x, and g is another function, and that is from 0 pi by 2 up to the set of real numbers. Definition is gx is equal to cos x. Individually, you are to show that individually these two functions are 1 1 functions, that is f and g are 1 1 functions individually. But if you take the sum of these two functions, this new function f plus g is not 1 1. You are to prove that one, and it is a very important question. In the question, it may give also the closed interval 0 pi by 2. This one, closed interval 0 pi by 2. So in both the cases, you can write the answer as same. I am going to write the answer for this solution, and in both the cases, whether it is an open interval or whether it is a closed interval, in both the cases you may write the same answer for the question. You see the solution. So to check whether a function is 1 1 or not, this is the method. X1 x2 belongs to the domain set. Then we have fx1 equal to fx2. Fx1 means sin x1 equal to sin x2, and sin x1 equal to sin x2, and x1 x2 in the principal branch. You see 0 to pi by 2 is in the first quadrant, and from the first year trigonometry branch, you know that if in case the numbers sin x1, sin x2, sin alpha, sin a, sin theta, these numbers, if these numbers are in the principal branch or in the first quadrant, then from here you can directly write, actually this is the general solution, but you can directly write x1 is equal to x2 because this is in the principal branch. So I am going to write that one, x1 is equal to x2 as x1 x2 belongs to the principal branch 0 pi by 2, mean in the first quadrant, mean n is equal to 0. This one, n is equal to 0, mean it is 0, minus 1 power 0 is also 0, so x1 is equal to x2. But this is actually the general solution for this equation. You know that one from your first year class 11 course. Okay, so come to the second function, mean gx. Again gx1 equal to gx2, taking from that. So this concludes f is 1 1. So now you see for the function z, it is gx1 is equal to gx2. Therefore cos x1 is equal to cos x2, and general solution for cos x1 is equal to cos x2 was x1 is equal to 2n pi plus minus x2. This one, 2n pi plus minus x2, but it is in the principal branch. Therefore n is 0. So x1 is equal to x2 as this is in the first quadrant, and so the function is 1 1. So z is 1 1. It is clear. Okay, come to the second part of the problem. The second part, to find the sum of the function f and z. And when we want to find the sum of two functions, first of all you are to find the intersection of the domains of the two functions, and domains of these two functions given in the question are same, 0 pi by 2, 0 pi by 2. So intersection is also 0 pi by 2. Therefore the domain of the sum of these two functions, mean f plus z, domain of f plus z will also be 0 pi by 2, and the function is defined like this. Now the function f plus z is defined as f plus z is, it is going from 0 pi by 2, this is domain, and to the set of real numbers r, where f plus z of x is equal to fx plus gx, and fx is sin x, gx is cos x. You have to write that one, f plus z whole of x is equal to sin x plus cos x, and x is belongs to this interval. Okay, so this time you are to show this function is not 1 1. That means you are to find one counter example to support that statement. So let me take two values of x such that they are different but images are same. So let me take x is equal to say pi by 6 and pi by 3. In that case you see, if you take x is equal to pi by 3 6, then and x is equal to pi by 3, both are belongs to this interval. So f plus z of pi by 6 will be equal to sin pi by 6 plus cos pi by 6, that is half plus root 3 by 2, and it is 1 plus root 3 by 2. And for this point, f plus z of pi by 3, sin pi by 3, cos pi by 3, it is root 3 by 2, this is half, and it is also 1 plus root 3 by 2. You see this image is same, but the pre-image are different. So pi by 6 not equal to pi by 3, but f plus z of pi by 6 not is equal to f plus z of pi by 3. So this has broken down the condition of surjectivity, mean function is not onto. So f plus z is not onto, and that is the complete solution of the problem. Also homework, this is a homework for you. Consider the identity function, this one defined by this one. You know the definition for identity function. Show that although in is onto, this time in is onto individually, but in plus in, this is not onto. You have to prove that one. So you can solve this problem with the help of this one. Previous question it was to show 1 1, and this is to show onto. So try yourself. If you have any problem, then ask me over phone. Okay, so come to the next question. So now come to the question number 17, and this will be the last question of the chapter, types of function. So that the exponential function, this one is 1 1 function, but not onto. And there is a second part of the problem, is whether if you change the codomain of the function with the positive real number set, then what will happen to the function. So first you show the function is 1 1, and that is very simple. You know that one. Let x1 x2 belongs to R such that fx1 equal to fx2. By using this definition, we are writing e to the power x1 e to the power x2, and obviously it will give us x1 is equal to x2, and therefore the function is 1 1. Okay, so to check 1 2, you are to take y belongs to the codomain set. So y is in the codomain set such that y equal to fx, fx is e to the power x, and from here x will be equal to, you are to express x in terms of y, so x is equal to log of y. And here you see this function will define this expression will defined only when y is a positive number. Otherwise, inside logarithm, if you give 0 or some negative number, it is an undefined number, you know that one. Therefore the range of the function is the set of all positive real numbers. Okay, so you write that one. This is defined only when y is belongs to the positive set of real numbers, that means this one. So domain is codomain is R, and the range is R naught plus, therefore it is unequal, and therefore it is not onto. So RF is equal to R naught plus or R0 plus, mean the positive real number set, it is not equal to the range codomain of the function, and therefore the function is not onto. So the function is not onto. But you see, if you change the codomain this one by R naught plus this positive set of real numbers, in that case the codomain is R naught plus and range is also R naught plus, and in that case the function will be onto. So we write that line only. So clearly, if the codomain is replaced by this set, the function will be onto. So this completes the solution of the problem as well as the chapter. Some other questions given in your exam, then from this class or from this video, what you have learned, it is sufficient to solve all types of questions that may be asked in your exam. Okay, so we finish this class here, and I am coming with a new video and with a new chapter, that is the chapter composition of function and inverse function, in the subsequent video. And till then, thank you very much.